Uh, in the previous video, we tried to understand the working of RS flip-flop and working of clocked RS flip-flop, and we tried to interpret the disadvantage of RS flip-flop, where we had to store one bit at the output we require two trigger input, and if both the trigger inputs are one, the output is a forbidden state. To remove that disadvantage, we design D flip-flop. See the construction, it is a modification of clocked RS flip-flop. So to draw clocked RS flip-flop, first draw the block diagram. As I'll start like this: S, R, Q and Q bar. I will use the symbolic representation S, R, and this will be the NOT gates, AND gates, which will provide the clock and the two trigger inputs. This is similar to the diagram of clocked RS flip-flop. And what we will do is, between these two inputs we will connect a NOT gate. That's all. This will remove the disadvantage of clocked RS flip-flop, and that type of flip-flop is called as D flip-flop. Let the input be D. So if you try to understand the working of this circuit, let us try to interpret the truth table with, again, initial condition Q is equal to 0, Q bar equals to 1. Here it will be clock, D, Q and Q bar. You can easily interpret the working. First, tell me what happens when clock is 0. When clock is 0, both the AND gates are deactivated or disabled. So both the inputs S and R both will be 0. And if both S and R will be 0, there will be no change in the output condition. At that point, whatever be the condition at D, we don't care. Now when clock is 1, say D is equal to 1. Clock is 1 and D is 1. When you make D equals to 1, what happens is the other input becomes 0. So for the first AND gate, the input is 1 and 1, and for second AND gate, the input is 1 and 0. So for the first AND gate, the output is 1, and for the second AND gate, the output is 0. So S1 R 0. Trigger has been provided to S. S stands for set. So Q will become 1, Q bar will be 0. So this is the set condition. Similarly, when clock is 1 and D is, say, 0. So when clock is 1 and D is 0, what happens is, for the first AND gate, input is 0 and 1. So it will be 0. And for the second AND gate, what you can see is, for 0 will be complemented at this point, it will be 1. So for the second AND gate, the input is 1 and 1, the output will be 1. So S0 R1, trigger has been given to R. R stands for reset, and reset means Q0, Q bar 1. And if you can understand, the inputs cannot be, both inputs cannot be 1 simultaneously. Therefore, the forbidden state can be easily avoided. So this is the widely used flip-flop called as D flip-flop. I hope you have understood. Hello students, we will continue with chapter number 5. In the previous videos, we tried to understand what exactly flip-flop is. We tried to understand different types of flip-flops: RS flip-flop using NAND gate, NOR gate, and then clocked RS flip-flop, and then clocked D flip-flop. Now the next type of flip-flops are flip-flops with feedback. Under this heading, we will try to understand two flip-flops. The first one is called as JK flip-flop, and the second one will be JK master slave flip-flop. So let us start with JK flip-flop. The circuit diagram for JK flip-flop will be the same as clocked RS flip-flop. S and R are the two inputs, Q and Q bar are the two outputs. For clock input, we will add additional AND gates. One input of both the AND gates will be connected together and called as clock, and then we will provide the two inputs. In case of SR flip-flop, we mentioned here as S and R, or if R and S are inverted, so here R or here it will be S. But in case of JK flip-flop, these two inputs will be called as J and K. Now you try, of course this circuit diagram is similar to what we have done for clocked RS flip-flop. The operation will be exactly same. But now we are trying to understand flip-flops with feedback, so of course there should be some modification so that it becomes with feedback. When you say with feedback, that means the output is connected back to the input. Feedback, that is, output is connected back to the input, which that means output also are part of input. So this is the modification in the circuit. Q output is connected as input to the second AND gate. This is Q now, and Q bar output is connected as input for the first AND gate. So this is feedback. So now, of course, if you don't consider this feedback, then Q and Q bar would definitely be dependent upon clock J and K. But now, as we have connected the feedback, Q and Q bar of course are controlled by clock J and K, but they also depends upon its own initial condition. This is very, very important flip-flop, because this type of flip-flops we are going to use to design counters and shift registers. So let us try to understand the working. What I'll do is I'll just make you explain the operation by drawing these AND gates. So what is the input for the AND gate? For the first input, in first AND gate, the input is, this is Q bar, J and clock. Here it will be clock, K and Q. Let us try to understand by truth table. So truth table will have, of course, initial condition Q is equal to 0, Q bar equals to 1. The input will be clock, J, K, Q and Q bar. What happens when clock is 0? When clock is 0, both the AND gates are deactivated. That means S and R, both the inputs are 0 always. And if S and R inputs are 0, that means there is no triggering which has been provided. Therefore, there will be no change in the output condition. So when clock is 0, irrespective of the condition of J and K, there will be no change in the output condition. So if clock is 1, now if clock is 1, these AND gates are enabled. So whatever input you are providing at J and K and whatever feedback is coming will be transferred through S and R. Let's say the first condition is J and K both 0. If J and K both are 0, one input of both the AND gates are again 0. Both the AND gates will be disabled. The output will be 0, S0, R0. No trigger has been provided. Therefore, there will be no change in the output condition. Next, clock is 1, J is 1, K is 0. Now you see, J is 1, K is 0. Now for this case, what is the input for the AND gate? What is the initial condition of Q? Q is 0, Q bar is 1. So what is the first input for the first AND gate? Q bar equals to 1 will be transferred here. So Q bar is 1, J is 1 and clock we had made 1. And for second AND gate, clock is 1, K is 0 and Q is initial condition, Q is 0. So Q is 0. So for the first AND gate, all the three inputs are 1. For the second AND gate, at least one input is 0. So output will be 0, which makes S is equal to 1, R equals to 0. S1, R0. S stands for set. Set means Q will be 1, Q bar will be 0. So Q will be 1, Q bar will be 0. So this is the set condition. Now Q is 1 and Q bar is 0. Next, clock 1, J0, K1. So J0, K1. But what is the initial condition now? Q is equal to 1, Q bar equals to 0. So Q bar equals to 0, J is 0, clock 1, K 1 now and Q is now 1. So for the upper AND gate, the output will be 0. For the lower AND gate, all the three inputs are 1, so output will be 1. So it will be S is 0, R is 1. S0, R1, R stands for, you have provided trigger to R. R stands for reset. Reset means Q will go back to its initial condition. So Q will go back to 0, Q bar will be 1 and this is the reset condition. So until now, if you check the truth table of JK flip-flop and or you compare JK flip-flop and SR flip-flop, it will remain same. But the most important condition is the last one, when both J and K are 1. In case of SR flip-flop, when both S and R inputs are 1, the output is a forbidden state. It is a not allowed condition. See the change here. If both J and K is equal to 1, see what happens is, and clock is 1. Now the AND gate's output will depend upon Q and Q bar. Say initially, what is the condition now? Q is 0, Q bar is 1. So this will become 0, this will become 1, 1, 1, 1. The output will become 1, 1, 1, 0, the output will become 0, S1, R0, the flip-flop will set. That means if previously flip-flop was reset and you give J and K 1, it will set. Set means Q will be 1, Q bar will be 0. Now let us try to understand what happens if already it is set and you give J and K equals to 1 and make clock equals to 1. So what happens is, when J and K is 1, clock 1, and if the previous stage of the flip-flop is like Q is equal to 1, Q bar equals to 0, then what happens? This becomes Q is 1, Q bar is 0, upper AND gate 0, 1, 1 will be 0, lower AND gate 1, 1, 1 will be 1, which makes S0, R1, R1, trigger given to R, R stands for reset, so output will reset. That means Q will 0, Q bar will 1. Or in other words, what we can say is if we make J and K 1 and we keep on giving clock pulse, what will happen? If it is previously reset, it will set. If it is previously set, it will reset. It will keep on changing from set to reset, reset to set. So we say the flip-flop works in toggle mode. So this is the most important condition of JK flip-flop, which we are going to use to design counters and shift registers. This is the symbolic representation of JK flip-flop. J, K, Q, Q bar and clock. I hope you have understood the working of JK flip-flop. Next is race around condition. This is nothing but a disadvantage of JK flip-flop. Now clearly we understood that JK flip-flop are the flip-flops with feedback, and we compared it with the working of clocked RS flip-flop. In clocked RS flip-flop, the output, when both the inputs are 1, the output is in forbidden state. It is a not allowed condition. But what is the advantage of giving a feedback? Giving a feedback, the output now toggles. When both the inputs are 1, the output toggles. That means if previously it is set, it will, when the clock pulse is given, it will reset, or if it is previously reset, when the clock is given, it will set. So if you keep on applying clock pulse, what you can see is the output will go from set to reset, reset to set, which we called it as toggling. But there is a disadvantage of JK flip-flop because of this feedback. See what happens is, let us consider this this disadvantage will occur when both J and K is equal to 1. You know, when J and K 1 and clock 1s, so the output of the AND gate depends upon Q and Q bar. That means previous case of Q and Q bar, if Q is equal to 0, Q bar equals to 1. So this 0 will be transferred over here, this 1 will be transferred over here. Therefore the output of the first AND gate will be 1 and second AND gate will be 0. S1 R0, it will set the flip-flop. That means Q will become 1 and Q bar will be 0. But if the clock remains high for a longer duration of time, see what happens. If the clock remains high for a longer duration of time, what will happen is, as soon as you give J and K 1 and clock becomes 1, of course the output Q will toggle from 0 to 1. But as soon as it toggles, the output is connected back to the input. So any change in output will provide change in the input, which makes Q is equal to 1, Q bar equals to 0. So now output of the first AND gate will be 0, 1, 1, the output will be 0, 1, 1, 1, the output will be 1, which makes S is equal to 0, R is equal to 1, and triggering given to R stands for reset, therefore Q will again go back to 0. That means the output will toggle, and the output, again the change in the output will be fed back to the input condition change, and therefore the output will change. That means initially when clock is 0, Q is 0 suppose. As soon as clock becomes 1, if J and K equals to 1, the output should toggle. It will go from 0 to 1. But if clock remains high for a longer duration of time, any change in output will be fed back to the input changes, and therefore the output changes, so output will again toggle to 0. Again the output will toggle to 1, and this toggling will continue until कब तक चलेगा ये toggling? Until the clock becomes 0, and when the clock becomes 0, the output Q may be 0 or 1, but that is uncertain. We don't know how it is going to end up when the clock becomes 0, or when the clock is deactivated. The output may be at that point will be 0 or 1, but what is the expected output? We said initially Q is equal to 0, Q bar equals to 1, and when J and K is 1 and clock is given, the output should toggle to 1. That means Q should 1, Q bar will be 0. But if the output will keep on toggling until the clock becomes 0, when the clock becomes 0, the output may be 0 and 1, and that uncertain condition is called as race around condition. And let us try to understand why exactly this is happening. See, output is directly fed back to the input. Any change in output will produce change in the input. As soon as you give input, the circuit will take nanosecond for the output to change, and if the clock remains high for a longer duration of time, output change will certainly change the input condition, and if the input is changed, again the output will change, so output will keep on changing until the clock is deactivated, and when the clock is deactivated, there will be an uncertain condition which will be there. So we have to remove that uncertain condition, which is called as race around condition. So basically the problem is, as the output is directly connected back to the input, change in output will produce change in input, and change in input will directly affect the output condition again. So what we have to do is, in the next flip-flop we will have two sets of SR flip-flop, one for input, one for output. That means when output is changing, input will be deactivated. When the input is changing, the output will be deactivated. In that way we can remove this race around condition. So I hope you have understood race around condition. Hello students, the next circuit which we'll try to understand is JK master slave flip-flop, and this JK master slave flip-flop has been designed to remove the disadvantage of JK flip-flop. I hope you remember the race around condition. When both J and K is 1 and the clock remains high for a longer duration of time, the output will keep on toggling, and it will keep on toggling until the clock becomes 0, and when the clock becomes 0, the output will be uncertain. To remove that uncertainty, we design JK master slave flip-flop. See the construction part. Now what we will do is, instead of using one SR flip-flop, we will use two SR flip-flop. One is called as master, the other one is called as slave. The other one is called as slave. The basic construction will remain as it is. So this is clock, this is J, this is K, and the output will be fed back to the input. So this will be your Q, and this is your Q bar. So now we have two stages, one for input and one for output. 1, 2, 3, 4. See, for the first AND gate we are giving clock pulse over here. Now what we will do is, from this clock, we will take one connection and we will connect it a NOT gate. So what will be this? It will be CLK bar, that means complement of clock. This entire portion is called as master. This is the first stage, and the second stage is called as slave. Now because of this NOT gate, when clock is 1, these two AND gates will be activated, but when clock is 1 through NOT gate, clock CLK bar will be 0. This is 1, this will be 0, so 3 and 4 will be deactivated. So if input is provided here, the input will change the output condition of only the first flip-flop, that is master, not the output, because these two AND gates will be deactivated. But that means change will occur only up to this point, not beyond that. But when you make clock equals to 0, what happens? CLK bar will become 1. As soon as this becomes 1, these two AND gates are deactivated, these two AND gates are activated. So now whatever input which has been reached up to this point will reach SR flip-flop. It will change the output condition, and you know, as soon as the output is changed, it is fed back to the input, but at that point clock is 0, so input is deactivated. So what happens is either master or slave will work, and in that way the uncertain condition will be removed. That means we can overcome race around condition by using JK master slave flip-flop. Let us step by step understand the working of JK master slave through the truth table. So truth table. Again we will start with Q is equal to 0, Q bar equals to 1 is the initial condition. Clock J, K, Q and Q bar. So Q is 0, Q bar is 1. So here the input will be 1, here Q will be 0. Let's say the clock is 1 at this point. I'll denote 1 as higher point and 0 as low point, 1 or 0. So let's say initially clock is 1 and J and K both are 0. Of course, if J and K both are 0, there will be no change in the output condition of the first flip-flop, there will be no change in the output condition of the second flip-flop, and therefore there will be no change even when the clock goes from 1 to 0. Next important point, let us try to understand. Initially when the clock is 1, say J is 1 and K is 0. So when J is 1, K is 0 and clock is 1, so 1 1 1, the output will be 1 1 1 0 0, the output will be 0. S1 R0, set Q will be 1, Q bar will be 0. But at this point when the CLK is 1, CLK bar will be 0. So these two AND gates will be deactivated. There will be no change in the output condition until the clock remains high. When you make clock go from 1 to 0, so clock now becomes 0, CLK bar will become 1, and as soon as CLK bar is 1, these two AND gates will be activated. Now the input which has reached up to this point will be transferred here, so this will be 1, this will be 0, S1 R0, Q becomes 1, Q bar will be 0. This is the set condition. Exactly on the same lines, let us try to understand what happens with this initial condition of Q is equal to 1 and Q bar equals to 0. We are giving J equals to 0, K equals to 1. So J is 0, K is 1, Q is 1, Q bar is 0. Let's say clock is 1. If clock is 1, CLK bar through this NOT gate will be 0. So clock is 1. So 0 0 1 will be 0, 1 1 1 will be 1, S0 R1. Trigger has been given to R. R stands for reset. Reset means Q will be 0, Q bar will be 1. So whatever change in the input which has been provided has reached up to only the master level because CLK bar is still 0. Now when the clock goes from 1 to 0, CLK becomes 0, CLK bar will become 1. Now 0 and 1 will be 0, 1 and 1 will be 1, S0 R1, R stands for reset, so Q will become 0, Q bar will be 1. So Q will be 0, Q bar will be 1 and the flip-flop will reset, right? And next again J and K when both are 1. Now let us see whether the circuit output condition become certain or not. See what happens is, now again I'll start with clock 1, so CLK bar will be 0. What is the initial condition? The flip-flop has reset. Q is 0, Q bar is 1. So Q bar is 1 and Q is 0. See what happens is, initially if it is reset and if I give J and K equals to 1 and I give clock, the output should toggle. Toggle means if it's already reset, it should get set. Let us check if it is set or not. So 1 1 1, the output of the first AND gate will be 1. 1 1 0, the output of the second AND gate will be 0. S1 R0 set, Q becomes 1, Q bar will be 0. So the input change in the input will has reached up to the first level, master. Now when you make clock equals to 0, clock equals to 0, CLK bar will become 1. So 1 and 1, the output will be 1. 1 and 0, the output will be 0. S1 R0, the flip-flop sets 1 and 0. But any change in the output will be fed back to the input. So Q bar will now become 0, Q will become 1. But will that change the input condition? No, because clock is 0. So output stays at that point. That means it is set now. So when it was already reset and when we gave J and K equals to 1 and we gave clock pulse, the flip-flop set and it will remain in its own condition. There will not be any race around condition. So by using two SR flip-flops, we can design JK master slave flip-flop and we can avoid race around condition. So if initially it is set, if you give J and K 1 and give clock pulse, the flip-flop will reset, and we say the flip-flop works in toggle mode. This is a very important condition. When J and K is equal to 1 and when you keep on giving clock pulse, the flip-flop will keep on toggling from 0 to 1, 1 to 0, set to reset, reset to set. Now see the symbolic representation. The symbolic representation which we have drawn for JK flip-flop was like this. Now for JK master slave flip-flop, it will be exactly same J, K, Q and Q bar, but there will be change in the clock sign. What you can see is there is a bubble sign. Now what you can see is in JK flip-flop, what happened is when the clock is 0, the circuit was deactivated. So when the clock goes from 0 to 1, only the circuit activated and then the input will be transferred to the output. So output changes when the clock goes from 0 to 1. It is called as positive edge triggering. It is called as positive edge triggering. And in second case, that is JK master slave flip-flop, what happens when the clock goes from 0 to 1, that means clock becomes 1, what happens is clock goes from, if it is 1, this is 0, and when it is 0, it is 1. That means the output will change. The output will change when the clock goes from 1 to 0. When it is 1, only the input is activated, output is deactivated. When the clock goes from 1 to 0, CLK bar will become, the output will change. So output will change when the clock goes from 1 to 0, high to low. So that type of triggering is called as negative edge triggering. This is the difference between JK flip-flop and JK master slave flip-flop. In JK flip-flop, the output will change when the clock goes from 0 to 1, and in JK master slave flip-flop, the output will change when the clock goes from 1 to 0. This has to be understood, this has to be remembered, so that we can easily understand the working of counters and shift registers. I hope you have understood. The next topic is concept of preset and clear. In all the previous flip-flops which we have tried to understood, that is SR flip-flop, D flip-flop, JK flip-flop, JK master slave flip-flop, in all those flip-flops, the output changes when we apply the clock pulse. When we activate the control input, when we apply the clock pulse, only then the output will change, or else the output will not change. but sometimes it is necessary the output should change without applying clock pulse. So what we have to do is we have to add two more terminals to the circuit called as preset and clear. As the name indicates, preset, that means if without applying clock pulse you have to set the flip-flop, you have to activate this terminal, and clear, as the name indicates, if the output has to reset to 0 without applying clock pulse, you have to activate this terminal. We will try to understand this concept by using clocked RS flip-flop, S, R, Q, Q bar, and now let us try to understand. Say these are the two inputs. This is AND gate 1 and gate 2. One input of both the AND gates will be connected together, clock, and this is S dash and this is R dash. This is the circuit diagram for clocked RS flip-flop. Of course, to add these two terminals we have to make certain modification. Why I am adding this preset and clear? Just look at this circuit. What happens when the clock is 0? Until the clock is 0, the AND gate will be disabled. Whatever be the input you are going to provide at S dash and R dash, will that going to reach to SR flip-flop? Of course not. And if S and R are 0, there will be no change in the output condition. So when clock is 0, there will be no change in the output condition. But what we want is that we want to change the output, or we want to set the output or reset the output without giving clock pulse also. So therefore we have to add two terminals. See the modification which I am going to do. What I am going to do is I am adding an OR gate over here, and the two terminal I will add it over here. So this is preset and this is clear. Let us try to understand the working by the truth table. Truth table. So now this is clock, this is R dash, this is S dash, preset, clear, Q and Q bar. Let's say initially Q is equal to 0, Q bar equals to 1. So what happens when clock is 0? When clock is 0, the AND gates are deactivated. We don't care about the condition at R dash and S dash. So when clock is 0, this condition will prevail. Now if preset and clear both are 0, see what happens. When clock is 0, AND gate output of both the AND gates will be 0, and if preset is equal to 0 and clear is equal to 0, for OR gate what is the input? 0 and 0, the output will be 0, 0 and 0, the output will be 0, S0, R0, there will be no change in the output condition. Now still clock is 0, we don't care about R dash and S dash. Say now preset is 1 and clear is 0. So what is the input for the first OR gate? 1, 0. And what is the property of OR gate? If any one of the input is 1, the output will be 1. So 1 and 0, the output will be 1. And here 0 and 0, the output will be 0, which makes S is equal to 1, R is equal to 0. Trigger given to S. S stands for set. Set means Q will be 1, Q bar will be 0. Similarly, when clock is 0, we don't care about the condition of R dash and S dash, and we make preset is equal to 1 and clear equals to 0. Preset is equal to 0 and clear equals to 1. So for the first OR gate the input is 0 and 0, the output will be 0. For the second OR gate it is 0 and 1, the output will be 1, which makes S is equal to 0, R is equal to 1. Trigger given to R. R stands for reset, and reset means Q will go back to its initial condition. Q is 0, Q bar equals to 1. So from this truth table what we can see is, even without giving clock pulse, if we activate preset and clear terminal, it will set and reset the output of the flip-flop. So there will be two additional terminals called as preset and clear, which will set and reset the output without giving clock pulse. I hope you have understood. The last topic under the heading of flip-flops is the designing of T flip-flop. Of course it will be with preset and clear terminal. So T stands for toggle flip-flop, and we already know that how a flip-flop can be used in toggle mode. we can use JK master slave flip-flop in toggle mode by keeping J and K equals to 1 at logic 1. If you keep at logic 1 and if you keep on giving clock pulse, the output will be set, reset, set, reset, which we will call as toggle mode. So for designing a T flip-flop, it's very simple. You have J, K, Q and Q bar, and both J and K input connected together and connected to logic 1. This is the clock input. This clock inputs indicate that the output will change only when the clock goes from 1 to 0, which is called as negative edge triggered. This is Q and this is Q bar. So this is a basic diagram for toggle flip-flop. Now we have to design with preset and clear terminal. So we have to add 2 more terminals to it called as preset and clear. Now both the terminals which you can see are active low. Active low means they will be activated when 0 is given to them. If 1 is given to them, they will be deactivated. Now in the previous video when I try to explain you concept of preset and clear terminal, there the preset and clear terminal were activated by giving 1. When preset and clear both are 0, there will be no change. When preset is 1 and clear is 0, preset is activated. That means the output will set. And when preset is 0, clear is 1, clear will be activated. That means output will be reset. But when the circuits are designed in the form of integrated circuits, IC chips, these preset and clear terminals are active low. Active low means they will be activated when 0 is given to them. Of course, it is a complement thing, right? Preset will be, if preset is 0 and clear is 1, according to this chip, preset is 0, clear is 1, which is going to activated. Preset is 0, clear is 1, and these two inputs are active low. 0 doge to active hoga. That means preset will be activated, clear will be deactivated. And if preset is 1, clear is 0, listen carefully, preset is 1, clear is 0. So out of these two terminals, which is going to activated, as clear is 0 and it is active low, this will be activated. Let us try to understand the same thing by using the truth table. It will be much more easier for you to understand. Truth table. Again, I'll start with Q is equal to 0, Q bar equals to 1. Then we have we have clock J, K, and then preset and clear, and then you have Q and Q bar. So let's say the clock is 1. If the clock is 1, we know the output will change. The output will change only when the clock goes from 1 to 0. If the clock is 1, the output is deactivated. That means when clock is 1, we don't care about the condition of J and K. But preset and clear terminals does not depend upon clock pulse. So let's say initially both preset and clear are 1. What will happen? Just remember that preset and clear terminal are active low. They will be activated only when 0 is given to them. But we are giving 1. So will there be any change in the output condition? Both preset and clear are deactivated. J and K are deactivated because clock is still 1. Right? So there will be no change in the output condition. Still clock is 1. We don't care about the J and K condition. Preset is 0. Now clear is 1. So as the clock is still 1, J and K goes under don't care condition, but now preset is 0, clear is 1, and preset is 0 and active low. So preset will be activated, clear is 1, active low, so it will be deactivated. So preset activated, as the name indicates, it will set the output. So Q will become 1, Q bar will be 0. This is set condition. Again clock is 1, we don't care about J and K condition. Preset is 1 now. clear is 0. So preset is 1, clear is 0. So both the terminals are active low. Now preset is 1, it is deactivated. Active clear is 0, it is activated, and when clear terminal is activated, the output will reset. That means Q will 0, Q bar will be 1. And now when clock goes from 1 to 0, when the clock goes from 1 to 0, we consider the condition of J and K flip-flop, and at that point if preset and clear both are deactivated, the output will definitely work in toggle mode. So this circuit operation is very important with respect to the next topic, which will be counters and of course shift registers. I hope you have understood flip-flops altogether.